Okay, so I'm going to do a couple of problems from the worksheet 3. The first one on the front page, all of these are where you're trying to calculate both the molarity of H, the molarity of OH, so the acid and the base, and the pH and the pOH. Remember, the most difficult thing is, or maybe it's not, is to figure out which one of the four values you have and then just plug and chug that number into all the equations to solve for the other three values. I'll work on number 3 here. It's a little more involved than the others, but here, number 3 is you have 33.7 grams of, this is phosphate, so phosphoric acid, are placed in 780 milliliters of water. Well, you're not directly told that you have H or OH or pH or pOH, but you have enough information to get one of them. And since this is an acid, you have an amount and a volume of the solution. So basically you're being given H because it's an acid. It's not OH but H. And molarity of H is going to be moles per liter. Well, we have the liters. It's 0.780 liters. But what we don't have is the moles. We do, however, have grams. We have 33.7 grams of H3PO4. We're going to divide that by the molar mass, which is the weight of 3 hydrogens, 1 phosphorus, and 4 oxygens. So that's 97.97 grams per mole. You divide that out and you get 0.34 moles. Okay, that's the moles in our equation, 0.34 moles. So 0.34 divided by 0.78 is 0.44 molar H3PO4. We talked about this in class. I think I solved this for all classes. That's the molarity of the entire H3PO4 molecule. But since that puts 3 H's in the water, the molarity of H, which is what we're looking for, is going to be 3 times that. So 3 times 0.44 is 1.3, and that rounding, it's 1.3. So that is our H. Now we have H, we can solve for all the others. We know that pH is the negative log of H. So it's the negative log of 1.3. You plug that into your calculator and you get negative 0.11. So pH is negative 0.11. pOH is going to be 14 minus pH. So it's 14 minus negative 0.11, or 14.11. And that's, we can always check. Remember, pOH and pH have to add up to 14, so 14.11 plus negative 0.11 is 14. OH, the concentration of base, it should be a small number. This is a strong acid, so it should be a very low concentration, but it is the anti-log of the negative pOH, so it's the anti-log of negative 14.11. You plug that into your calculator. We get 7 times 10 to the negative 15. Okay. This is a tiny little number, and that's okay. Our base concentration should be a tiny little number because this is an acid. Okay, and I'll move on and I'll do one from the back. And these are it's still the molarity equation, moles per liter, but it's with the end of being able to use the BCA tables. Okay, so I'll just do the first one here, number 6. It's BCA, you have to start with the complete bounce reaction. It's HCl plus NaOH. It's a double replacement, so we're going to switch the two negative things. We're going to have HOH, or water, plus sodium chloride. And it's all balanced 1 to 1 to 1 to 1. And here, we know that our BCA calculations have to be done with moles. I don't have moles, but I do have a volume and a molarity for the NaOH. So, and I know that molarity is moles per liter. I can rearrange and find that moles are molarity times liters. So I'm going to take my molarity of NaOH, 3.85. I'm going to multiply it by the liters, 0.0815 liters. And that gives me, on the calculator, 0.31 moles. So I have 0.31 moles of NaOH. And the point of doing that is, once we get moles, it's a 1-to-1 reaction. So I know if I had 0.31 moles of NaOH, I also had 0.31 moles of HCl. I'm asked for molarity of HCl. Molarity is moles per liter. I already have the moles, 0.31 divided by the liters, 56.5 milliliters, so 0.0565 liters. Did my math, and I end up with 5.5 molar HCl, which is, of course, also H.